Welcome to Talking Machines by Sue Park, the podcast where we talk machines, the bots, and the hottest AI papers off the press to demystify the world of artificial intelligence research. I'm Vic, and with me today is my lovely co-host, Alex.
Today, we're diving into a fascinating paper titled How to Predict Best Pretraining Data with Small Experiments by Allen Institute for AI, also called AI2.
This research tackles the ever-pressing question of how to choose the right pre-training datasets for large language models without breaking the bank.
Essentially, the authors propose a suite of models called DATADECIDE, which allows researchers to make informed decisions about which datasets yield the best performance at a lower computational cost.
I mean, who wouldn't want to save some cash while training those massive models, right?
Exactly. The key takeaway is that by conducting smaller-scale experiments, like testing with models of 150 million parameters, they found that the ranking from these smaller tests can predict the best-performing datasets for much larger models, achieving around 80% accuracy in predictions.
That's pretty impressive. It's like saying, hey, we can predict which benchmarks the models will score highly on, so no more trial and errors needed.
Instead of spending a fortune on huge models across multiple datasets, you can just run a few targeted tests and get solid insights.
And what's even cooler is that they also identified which benchmarks and metrics are the most effective for making these predictions.
Oh, that's sick.
Yes, they've even categorized the effectiveness of different benchmarks like MMLU and HelloSwag, so researchers can choose where to focus their efforts.
So, in essence, they're giving us a roadmap to navigate the often murky waters of pre-training data selection.
And let's not forget the vast array of data recipes they explored. 25 different datasets, each with unique filtering and deduplication strategies, were tested.
That's a significant amount of data to sift through. How did they manage to keep everything organized?
They utilized a systematic approach, running controlled, pre-training experiments and collecting over 30,000 model checkpoints.
Whoa, that's a serious commitment to data integrity, and they ran 3 random seed reruns for their largest models to account for variability, right?
Exactly. This meticulous setup allows them to quantify differences caused by random initialization and data order, ensuring their predictions are robust.
It's like they've thought of everything.
They really have. Plus, they discovered that using continuous likelihood metrics as proxies in small experiments can enhance predictability for certain benchmarks.
Interesting. So does that mean they're saying traditional accuracy metrics might not always be the best approach?
Pretty much. They found that these continuous metrics often outperformed discrete accuracy targets, which is a game changer for how we think about evaluation at smaller scales.
That's a great insight. It's like they're flipping the script on what we thought we knew about model evaluation.
Absolutely. And as Allen Institute for AI, also called AI2, always does, by sharing their models and evaluations openly, they're empowering other researchers to build on this work without incurring the same computational costs.
This approach could really democratize access to high-quality model training.
Exactly. And as we see more advancements in AI, this kind of resource sharing can lead to a more collaborative and innovative research environment.
Speaking of which, what specific metrics did they find to be most useful for these predictions?
They highlight that benchmarks like MMLU, ARC, and HelloSwag are particularly effective, but the degree of predictability varies significantly across tasks.
So, some tasks are just inherently easier to predict than others, right?
Yes. For instance, tasks like ARC Easy are much more predictable with lower compute, while others like HelloSwag require significantly more computational power to achieve good decision accuracy.
That's fascinating. It sounds like understanding the nuances of each task is crucial for researchers.
Definitely. And as they delve deeper into these metrics, we could see further refinements in how we evaluate model performance at scale.
That would be a huge step forward, so What's next for this research?
They suggest that future work could explore new evaluation methods and potentially refine their scaling law predictions even further.
Exciting times ahead. I can't wait to see how this evolves.
Me too. It's all about making AI research more efficient and accessible for everyone.
And that's what we're all about here, demystifying the tech behind AI and making it more approachable.
Absolutely. And with papers like this, we're on the right track to understanding the complexities of AI development.
Let's keep the momentum going and dive deeper into how these methodologies can be applied in real-world scenarios.
The paper really emphasizes the importance of understanding the scaling laws in AI models.
Right. The authors argue that as you increase the size of your model, the performance tends to improve, but it's not linear. You get these diminishing returns.
Exactly. So, initially, you might see significant jumps in accuracy with a little bit of extra compute or data. But as you keep scaling, the improvements start to taper off.
It makes sense. You can't just throw resources at a problem and expect to keep getting better results indefinitely. It's like trying to fill a bathtub with a bucket. At first, you see a big difference, but eventually, the water level just creeps up.
That's a great analogy, and it's crucial for researchers to understand where those diminishing returns kick in. If they know that a model will plateau at a certain point, they can make smarter decisions about resource allocation.
Definitely. The paper points out that some tasks benefit more from scaling than others, which is such a critical insight.
Right. They classify tasks based on how predictable the outcomes are when scaling. Tasks that are less predictable might require more experimentation to find the right balance of compute and data.
And this has real-world implications too, especially when organizations are deciding how much to invest in training large models. If they can gauge the potential returns on investment based on these scaling laws, it could save them a lot of time and resources.
Absolutely. It's like having a roadmap for AI development. The better we understand these dynamics, the more efficient we can be in advancing the technology.
Speaking of efficiency, the paper discusses different methodologies for evaluating model performance. They bring up some interesting metrics that could be more informative than the traditional accuracy measures.
Yeah, they do. Instead of just looking at overall accuracy, they suggest using metrics that can capture the nuances of a model's performance across different tasks.
That's such an important shift. For example, they talk about using metrics like task-specific accuracy, which can highlight where a model excels or struggles.
Exactly. This means that rather than relying on a single number to represent performance, we get a richer picture of how a model operates across various contexts.
And it could help identify potential areas for improvement too. If a model is performing poorly on a specific task, researchers could focus their efforts there instead of trying to boost the overall accuracy.
It's a more targeted approach, which I think is really clever. Plus, it encourages a deeper understanding of the model's strengths and weaknesses.
And that's so crucial for building trust in AI systems. If we can clearly articulate why a model is making certain decisions or where it might falter, it can lead to better user experiences and more responsible AI deployment.
Totally. The authors also emphasize that these evaluation methods could pave the way for more robust benchmarks in AI research.
Robust benchmarks could drive competition among researchers to improve their models based on measurable criteria rather than vague claims of superiority.
Exactly. And it could help standardize how we evaluate progress in the field. Imagine a world where we can easily compare models based on a set of agreed-upon metrics.
It could foster collaboration and innovation as researchers work towards common goals.
And the paper hints at integrating these methodologies into existing AI frameworks that could accelerate the adoption of better practices across the industry.
Right. It's like giving everyone a toolkit to build on. If researchers can leverage these new evaluation methods, they can refine their models more effectively.
And I love how the authors acknowledge that this is an iterative process. They're not suggesting a one-size-fits-all solution, but rather an evolving framework that can adapt as we learn more about AI.
It's like saying, hey, we're still figuring this out, and that's okay.
Exactly. The continuous refinement of methodologies is part of the research journey. The more we learn, the better equipped we are to tackle the next set of challenges.
And with the rapid pace of AI advancements, we need that flexibility. If we cling too tightly to outdated metrics, we risk stifling innovation.
Absolutely. It's a reminder that the landscape is always shifting, and staying adaptable is key to success in AI research.
I'm curious about how these insights will be applied in real-world scenarios.
That's a great question. It could be fascinating to see how companies start to adopt these new evaluation methods in their own AI projects.
And what that means for the future of AI deployment in various industries.
Right. There's so much potential for impact, especially as we refine these methodologies and apply them practically.
I can't wait to see how this unfolds.
The results section of the paper is where things get really interesting, especially when they start discussing how compute correlates with decision accuracy.
They found that there's a pretty strong relationship between the amount of compute used for predictions and the accuracy of those predictions. It's cool that they quantified this relationship, but TBH, it's not that surprising. Throw more money, throw more compute, and boom, you get better models.
That's true. But what's different is that they do the analysis on a benchmark level. They found that tasks like ARC and MMLU can be predicted with significantly less compute than more complex tasks like HelloSwag. This suggests that not all tasks are created equal when it comes to predictability.
Exactly, and it's not just about the compute itself. It's also about how well the different tasks spread out the performance metrics across the various datasets. Some tasks just naturally have a wider spread of performance, making them easier to predict.
That makes sense. It's like if you have a really clear winner in a race, it's easier to predict who's going to come in first than if there are several close competitors.
Exactly, and they present data showing how decision accuracy varies significantly across the 10 OLMIS tasks. It's a clear call to action for researchers to focus on the right benchmarks for their specific needs, instead of selecting what everyone else does.
Speaking of benchmarks, the paper also discusses the importance of continuous metrics over discrete ones for smaller scale experiments. It seems like they found that using likelihood metrics can improve prediction accuracy at these smaller scales.
Yes, they discovered that continuous metrics like correct prob and total prob often yield better decision accuracy than traditional discrete accuracy metrics. This is a bit of a revelation because it suggests that we might have been underestimating the power of these continuous metrics in smaller settings.
It's interesting how they connect this to the idea of noise and variance. They note that a low run-to-run variance combined with a wide spread of benchmark performance values enhances predictability. So using the right metrics can actually help minimize that noise.
Absolutely. By using metrics that offer a better signal, researchers can make better predictions without needing to rely on extensive compute resources. It's all about finding those sweet spots that allow for efficiency in decision-making.
And they also make recommendations for future research directions based on their findings. For example, they suggest that future work could extend the DATADECIDE framework with new evaluations or different prediction methods.
The ability to run new evaluations on their checkpoints without needing extensive compute is particularly compelling.
Their approach allows for empirical testing of different pre-training datasets, which is crucial for the development of more efficient models. That could really change the game for how we approach model training and dataset selection.
Right. By providing a suite of models trained on a variety of data recipes, they're essentially creating a more structured way for researchers to explore and validate their choices. It's a much-needed resource in an area that can often feel overwhelming due to the sheer amount of data and model configurations available, plus all the energy power that gets consumed for each training run.
And that ties back to their larger goal of making AI research more accessible. By reducing the compute costs associated with validating decisions, they're lowering the barrier for entry for many researchers.
Absolutely. It's a step towards democratizing AI research, which is something we desperately need. The more accessible this research becomes, the more diverse the contributions will be, ultimately leading to better and more robust AI systems.
They also touch on the implications for industry. As companies adopt these new evaluation methods, we could see a shift in how models are developed and deployed across different sectors.
For sure. Companies that leverage these insights can optimize their resources and improve model performance without the previously exorbitant costs. It's a win-win for both researchers and industry practitioners.
And the fact that they've released all their models, data, and evaluations is a huge plus. It encourages collaboration and transparency in the field, which can only lead to more innovative solutions.
It really does. This approach not only enhances the reproducibility of their findings, but also invites others to build upon their work, creating a ripple effect in the research community.
Today, we looked into AI2's DATADECIDE paper, which allows researchers to make decisions about pre-training data without needing to exhaustively train massive models every time.
The ability to predict which datasets will yield the best results at scale is a total game changer.
And the fact that they found that just a single small-scale experiment can give you an 80% accuracy on larger models, that's pretty clever.
It makes the whole process way more efficient. Instead of relying solely on scaling laws, which can be hit or miss, they're providing a more reliable baseline.
And let's not forget the importance of different metrics. Using continuous metrics for predictions really highlights how nuanced the evaluation process can be. Model evaluation is the hottest open research topic as of late. Perhaps we can dive into that in our next episode.
Thanks for joining us on Talking Machines today. We hope you enjoyed learning about DATADECIDE. Our goal is not to bore you, but fill you in on what's happening in the sci-fi, slowly becoming our reality era we're living in. And today, we learned about DATADECIDE.
Until next time, you can find us on Instagram at talking_machines_podcast.